let's learn a little bit about inverses. That was a great start. So I'm collecting data from this green function, and I am storing it in a spreadsheet so that I have x values and y values from this function. Spreadsheet's over here, it's hidden. So I've replotted the x's and the y's and then reversed them to get the inverse. So an inverse, just as simple as that, is reversing the domain and range of our graph. So this graph is the inverse of this one. Let's try another one. This time I'm giving you the equation so you can think about this data comes from the function square root of x plus 2 plus 3. Again, I'm gathering data. I'm going to store those in a spreadsheet, and then I'm going to plot those in reverse. So here is the inverse of this function. So I would challenge you to try to write what you think the inverse is. So I'll just start you out. Most of you agree that we would need some kind of an x squared. Okay, good luck. Try moving it around and see if you can get it to relocate over here. Okay, here's another thing to think about. What are the two inverses? This is y equals x squared, and this is its pal, x equals y squared. So I want you to think about one-to-one functions, and I want you to think about which piece of either of these functions would you keep in order to guarantee that both of the functions are one-to-one. Again, I will challenge you. I'm going to put this in and say, hey, that's the piece that I want for this graph. Now, what would be the matching piece for this graph? Maybe you have not done this before, but I'm going to show you that you can put a constraint on x right in here and make just one piece of that graph. There we go. So these two pieces are inverses. I don't know, maybe you can figure out how to keep this piece and thus this piece. Okay, so it's up to you. See if you can write the inverse for this graph. You may need a piece of paper and pencil, and the way we talk about it is by switching x and y and then solving for y. Good luck!